So welcome everyone to another session of the World of Microservices series. So today we are going to discuss about test automation. As you can see, this is a little different from what we as developers are generally used to. But nonetheless, this is a very, very important part of software development. And this is a part where QA department and the dev department both interacts heavily. So we are mainly going to see that how we can develop test automation for a microservice backend. But since this is something we have to put it into context, that's why I'm going to discuss a little bit about software QA and test and where does everything fits in. We are also going to take a look at integration test, the concept of integration test and unit test, because these are a little different. And when I'm going to show you the code, you will see that how this is different. We'll also see how we can do, if you are already familiar with spec flow or cucumber style languages, we'll take a look at how a test case or QA procedure can be derived directly from business cases. And these concepts are very important in software development, because in old days, when we tracked functional requirement from a document to code and back and forth, we had to do a lot of linking, that the requirement is actually being implemented in the code or not. We ensured that we had to do a lot of linking. Now, there are a lot of tools available, and we first will take a look at the concept. Automation, we have to understand a bit, because the main focus is to develop automation, but to do that, we have to understand a bit of principle. We'll see the differences between unit test and integration test. We will also see how we can use mocking in our unit test, and how we have to, what we have to do to create our integration test. And we will also discuss a little bit about test-driven development. So let's get started. Software quality assurance. Now, remember that software quality assurance doesn't mean only testing. It's a very big, all-encompassing or executing test cases, measuring performance of the system. It's not just that, it is everything. So I give you an example. Suppose you are writing code. You are writing code, but you will see that most teams, most software development teams in the world, they will allow certain syntaxes where other teams will not. So that is also part of software quality assurance. Like what you are, suppose the code that you wrote is perfectly fine, there is no bug in it, but you didn't put indent in there in the proper places. The lines are too long, it's not readable. It doesn't, it is not clear to someone who is maintaining it. It's very difficult to understand. So that's also a quality problem. But obviously that is something, it is not a part of software testing. So that's what I'm trying to say, that the software quality assurance is a very big concept, and software testing is actually a part of it. So you don't have to understand all these things. I mean, this is not really, I mean, mostly I'm a developer. So these are the things that development managers or QA managers, they care a lot about, because after all, what we are doing here, all of us, we are building software, and every one of us play a function in this software development process. Even the people who cooks for us in the kitchen, they are also very important part of the team. So the entire team actually is part of software quality assurance. So then we jump into software testing. So, I mean, there are a lot of QA engineers in this company and developers as well. So let me share something with you. I mean, you probably know that I started my career with Microsoft Corporation, but I do not remember that I have shared. I actually started my career as an SDET, that is Software Design Engineering Test. And for first 1.5 years of my 4 years in Microsoft, I was actually an SDET. And my main responsibility was to automate test cases. But that's a long time ago. But even when I joined Hewlett Packard as a full-time developer, I had to write a lot of test automation. That has changed dramatically after coming to Bangladesh. But anyway, what I'm trying to say, that if you're writing quality software, then it is quite normal that you will be asked to write test code. And it's not only for the testers, it's also for the developers. Okay, so now there are a lot of testing strategies in software QA. There are whole books. Like when I started my career in Microsoft, they gave me 2 thick books. So I was thinking, wow, I didn't learn anything in 4 years in university. Now I have to relearn everything. So I had to study the 2 thick books about software testing. I'm not going there. We don't need to go there. For the purpose of this session, simply understand that the phases, software testing is, it is related to the phases of software development, right? When a developer is developing his code, he actually writes the unit test. You are all familiar with it. Even the testers, the QAs, when they write their test code, they also write unit tests for their code. That was a common thing in Microsoft. Now, integration testing is a little different, and integration testing has different meanings. Integration testing is for a QA, it means that all the smaller parts are coming together. Think about a big team that is developing 20 microservices, and one team only develops 1 microservices, and they do not know about the other microservices that is being developed by other teams. So the QA team will be looking forward to all these microservices coming together and running in a system. So that will be what you call a system testing. Integration testing, on the other hand, I mean, if you put a narrow focus, then what it is? All your team members wrote code and it is put all together in a branch and you build it. Then in the whole system, you run the integration testing. So if you didn't understand that, no problem. When we look at the code, we will all understand that what is happening. So don't be bothered about it. Now, let me quickly start the test automation part that is most important. So very soon, I'm going to show you this test code. So we have discussed about unit test and integration test. I'm going to show you that how you can write unit and integration test. There is a bit of trick to it. It depends. We will see, look into it. But here also that the big question that everyone asks, even in my last company, what is the benefit in writing automation? The simple answer is automation is necessary if you want to sustain a product for a long time. Without automation, it becomes very, very hard. I am telling you this from experience. If you are writing a product that has a very short life cycle, and once you have developed it, you don't have to care for it, then I mean, writing automation doesn't make much sense. But if you need to sustain this product for 10 years, you have to have some sort of automation. I don't care if it is like 30% or 80%, as much as you have actually is the better. Any of you who have been developing software long enough must have felt that, because once the product goes into maintenance phase, when the new patches are being developed and everything, if it is a big product, if you do not have automation, it becomes very, very difficult to run the regression tests. So automation, test automation obviously has value. Otherwise, no one will be developing them. Right, so past the big question, our main focus will be to develop test cases. So actually automate test cases, but to automate test cases, first you have to understand that what is the requirement of a test case, right? So to do that, you have to see a test case, a standard test case from a developer's perspective. So from the developer's perspective, what do you see? We see test cases as a group of steps, sequential steps, right? And every step is followed by a predetermined validation. Okay, that is the principle. When you see in the code, it will be much easier to look at. Now, you see, developers understand code better rather than, I mean, reading book. I'll better read code. So now, the objective of it might be to verify behavior. So every test case comes from a behavior. Generally speaking, every test case comes from a functional requirement or a business case, right? A business case, then from a business case, the developer develops the code, the product code, and testers will develop test cases from it. And if they can, they will automate it. That is how it works. This is the reason a lot of teams use this BDD style development, behavior-driven development. Now, if you are familiar with this Cucumber language or Gherkins, you have heard about it. So we are going to see what it is. This is a simple example of how a test case can be written using the BDD frameworks. So I have used the spec flow. Take a look at this one. I mean, this thing, what is written here? This case looks much like a business scenario. Okay. It is written in very simple, human readable language. That is something a person who is not a coder, who doesn't understand code, even they will understand. So you don't have to be technical to understand that. From this, we can develop test code. And how we can do that, I'm going to show you. Yeah, this is, we are going to see that how you can use the spec flow to develop test cases. But before we can go there, let's take a look at unit test and mocking. So mocking is a very common part of the unit test. Why? Because as the name suggests, a unit test is only supposed to test the unit, nothing else. It's not meant for testing the dependencies. Now, you might be thinking that how is that relevant? We are going to see how this is relevant. Think about it. Suppose you have a service class in the application layer of your microservice. It has upper layer and it has lower layer, right? The lower layers might be the data layer, the persistence layer, whatever, how you have written your microservice. But when you are writing unit test for this service class, you don't have to test you don't have to test the functionality of the lower layers. I mean, that is not what unit test is for. So what you do, you mock the lower layers. We will see how very soon. If you have used mocking before, you already know how to do it, but we will see how and how this thing fits into our microservice test automation. Integration test for microservice. Integration test, on the other hand, it is, I mean, you cannot mock things here. You cannot. You have to actually have all the layers of a microservice, every layer created in memory together with the in-memory server. Now, the big question is the microservice system has dependencies outside of the microservice, that it has dependency on the database. It has dependency on the RabbitMQ, I mean, whatever service bus it is using. It has a lot of other dependencies. So when a integration test is being run, how do we handle that? That's the first big question, right? Because when you are developing integration test or unit test, your team will expect that this will be a total automated procedure. That means these test cases should be able to execute when you are using build pipeline, CI. So if you have written test that doesn't execute, not capable of running during build procedure, automated build procedure, that is no good. It adds no value. So how we can keep the objective of our integration test and also develop it totally in memory with its dependencies, we'll see soon. Now, test-driven development, actually what it is written here is just the principle. If you have never done it, it's very difficult to understand. I did test-driven development for about a couple of years in Hewlett-Packard. I'm telling you, it's not easy. So generally, it happens when the project goes into near maintenance phase. When the product is being developed, it's very difficult to do test-driven development. It is, of course, possible, but for that, the entire team have to be consist of like extremely capable engineers. Now, remember that test-driven development is a lot faster than normal waterfall model. It works very fast. You can develop things very fast. You can deliver very fast. But the drawback is if your team is not extremely capable and if you do not have very good understanding between your team members, it's very, very difficult thing to do. But nonetheless, it is possible. All right, so I'm not going to discuss a lot of principles today. So what I'm going to do, I'm going to show you the code. So let's start with the unit test. My unit tests are written dependent on the microservice system that I showed you. Now you see I have two microservices. One is the order microservice, another is the payment microservice. The payment microservice is written using n-layer strategy. So it has an application service layer when the main service class is a class. Like normal service classes you write for your microservices, and it has its dependencies injected into it, right? Dependency injection. So if I am going to write unit test for this class, how do I write it? That is the first question for unit testing. So we have already discussed that we need to use mocked object. Let us see. This is written with X unit. If you choose to write it with any other framework or test framework or test runner, that is perfectly fine with me. That's not a problem. So take a look at the payment service test. This is the test class. And here we have the test method, practice test method. So what is happening here? First, I have created these mocked objects. So take a look at here. The payment service has 3 dependencies: the payment repository, the mapper, the event bus. All 3 has been mocked here. These 3 mocked objects. And these 3 entities, it is actually data. I mean, creating test data. That's its purpose. So inside the constructor, I initiate the mocked objects. And I create the data. Then what I do, I have to do this mock settings. So once the mock settings are done, I create the service here. What I did, the dependency injection, in the dependency injection, I pushed in the mocked objects into the service. That's how I created the service class inside the test method. After that, I'm calling this add payment async. Now, this is a simple test case. I'm testing that if this service is actually capable of adding the payment. And after that, I am running this validation. It's a very simple, straightforward test case. There's nothing complicated in it. The main complex part is that you have to understand what to mock and how to mock. This is how you can test a service class. On the other hand, you see in my payment microservice, I also have the data layer. In the data layer, I have the repository, right? Now, if I want to test the repository, what do I do? In the repository, let's take a look at the repository class. Repository class is built on the top of DB context, right? DB context is pushed into here. So now if I write a test case for the repository, am I going to mock the DB context? Well, you can. I'm not asking you not to, but I didn't. I use this in-memory database. There is a package in, I mean, there are a lot of platforms, they offer this in-memory database service. It's very important for like testing or other purposes as well. Very lightweight in-memory database. So what I did, I created an in-memory database and pushed it into my repository class. That's it. After that, I can write the test cases for my repository class. So, okay, now you understand that how you can write for an n-layer microservice. If you are asked to write unit test for an n-layer microservice, how you can do that. Now, you see that writing unit test is for controller, I mean for presentation layer. If you do not have an UI, then it's not really that meaningful, because when you are writing integration tested, you have to test the controllers normally. So there is no point in writing multiple tests here. But of course, if you are asked by your client or your manager that you have to write unit tests for your controller, the same principle can be applied there. Another thing I want to show you, which is about my order microservice. So you see, unlike my payment microservice, order microservice is CQRS, right? The command and query classes are separate, and it has used mediator. Well, don't worry, there is no need to sweat. That's also very easy to do. In this code, you will find that how you can write test case with mocked object for a command class. So all you need to do actually create the handler instance. Once you have created the command handler class, the instance of the command handler class with mocked object or in-memory database, whatever you are using, you are good to do the test. So see what I did. I created my DB context as in memory. So my CQRS doesn't use repository. DB context is directly pushed into the command and query classes. So I created in memory DB context, and I created this mocked object for my mapper and the event bus. After that, what I did, this is the test data and mocked objects. And I created the handler, instance of the command handler with the in-memory DB context and the mocked objects for event bus and mapper. Now, if we make a comparison with this class and the payment service class, now you see the service class is actually created with 3 mocked objects with mocked repository. Here it is a little different. I'm pushing in memory database directly. I didn't actually mock the database. So then I simply call this class with the test data, this method handle, and that's it. It's nothing too difficult about it. Actually, it's quite easy. Now, we are done with the easy part. Okay, writing unit test with mocked objects and everything, if you understand it well, then it's actually pretty easy. Of course, I mean, you have to verify your logic and everything, test logic and this thing. And honestly, unit test sometimes can also get quite complex if the business logic you are writing is complex. It can get quite complex. So generally for a unit test, what you write? You write 1 positive, 1 negative. That's the normal idea. Of course, you can write more. Generally, you write 1 positive and 1 negative. So, but that is the easy part. Now we take a look at how we can write integration test. Now, integration test is not as simple as unit test. For unit test, you actually do not have to create any test infrastructure or anything. It's pretty simple. It's like if all your dependencies are injected, you then mock them and inject it, and then it is ready for testing. But for integration test, it's not so simple. You actually, I told you, you cannot use mocking because that is not the purpose of integration test, right? You have to test the whole thing together. So to do that, let us take a look at how we can create integration test. This is my integration test for the payment microservice. Now, payment microservice is an n-layer microservice, right? So for that, to facilitate that, I created a simple test infrastructure, which is my test provider. The test provider gives you 2 things: the HTTP client that can call mimic the microservice endpoint directly, and the DB context. It gives you a pointer to the DB context, because in integration test, what you do, you first send with Postman or any sort of REST API or whatever it is, you send in the data when the microservice is running on a container. Then the data goes into the microservice and it gets inserted into the database, right? So how you test it? The testers do what? They write some thing in the Postman, they send a post request, then they check the database if the data is created. They also check that whatever reply I am getting from the microservice, if it is appropriate or not. So that's how the test goes. The same thing here will. So the HTTP client, it will facilitate those HTTP calls you make with Postman, and the DB context, this will facilitate the search that you run in the database. Now, how it is created? It is created with this class, Web Application Factory. So what does the Web Application Factory do? It takes this program.cs. I mean, in the old days, I mean, in .NET 5, you had this startup, but in .NET 6, you do not have startup. So you have to directly use the program. You have to directly use the program, and also you will have to expose your program as public in the microservice. Otherwise, I mean, the test code will not be able to test it. But to clarify, you also have to add this thing so that your program class is available to the test project. Once you have done that, then you are ready to use it. So see what happens. Two more important things. Handling the dependencies, because this is an in-memory server. So in-memory server, this means that when it is running in the CI pipeline, it will not have access to database. It will not have access to event bus, right? So what do you do? And you cannot mock them because mocking is not allowed in integration test. Simple. What I did from the services, from the DI container, I removed the actual implementation of the event bus and I filled it with a dummy event bus for testing. Now, there are a lot of in-memory event bus like in-service bus and other lightweight things that you can use if you so choose. But my integration test is actually not testing service-to-service communication. So it's a simple class, but if you want to test service-to-service communication or with multiple services, you can do that. Next thing I did, I took out the originally implementation of the DB context and filled it in with the in-memory DB context. Now I see I have a whole working microservice in the memory. Then I can go ahead and write my test. This is my test class. So all I have to do, I have to push in this test provider. The test provider gives me access to the microservices endpoint through the client. So here you see how I'm doing the post test. This is my test data. This is something a manual tester will be creating in Postman, right? So what I did, I'm creating the DTO object. Then through the client, I'm calling the API. I mean, this is exactly something a manual tester will be doing using the Postman, right? It will call the API and send the data. That is the same thing happening here, only inside the code. Once this thing, and then I'm verifying the response. This is something, again, a manual tester will be doing in his Postman, right? He will check that if the response I got from the API, if it is correct or not. That is the same thing happening here. And also then I am checking the database that if this entity is created or not. Now, again, I mean, this is not a perfect test case because you have to add a lot of asserts that I didn't because obviously I'm getting old and lazy. So then you can take a look at my get test cases. For the get, what I did, I first created the entities inside the database directly and made a get call and verified that if I am getting these entities or not. So that should satisfy the test case for your get. People could, of course, argue. And my colleagues reminded me that I actually have to check that if these two entities are created in this list or not. And I agree, you have to do that. And get by ID, again, I created directly in the database. And then I made a get call with this ID and verified if I'm getting the correct data or not. Put is a little more complicated because first you have to post the data, verify if you are getting the data or not. Then you have to update the data. Let me show you. So you create the data first for posting. Then you make the post call and verify that, yeah, the entity has been created. The record has been inserted in the database. You check the database. Then you make a put call. You update the abstract DTO again, you make a put call. You update the data. So once you have updated the data, then you are making another get call to verify that if it actually has been updated. So it's a little more complex, and delete is pretty much straightforward. Again, you create data in the database directly, you make a call to the API for delete, and then you verify if the data has been deleted. So that's pretty straightforward. Now, very, very big question. This API calls you just saw, it does not involve security because my microservices are not guarded. So it doesn't verify that if the HTTP call it is receiving has a token or not. It's not verifying that. But what if it did? What will happen then? Well, then your test infrastructure will become a little more complicated because there are two ways. First, you can do it with a hard-coded token, which is a very, very bad way of testing anything. Second is you have to create an in-memory identity server. Now, that is a tricky part, not difficult. I haven't done it, but I did it before. I mean, I actually have the implementation, but here I'm not going to show you. If you are interested and anyone wants to do, you can contact me. I'll provide it. I'll discuss with you and show you how to do that. So, all right, then let us see how we can run these tests. So the build has succeeded, test is running. You know what? All the test cases pass. So let's mess up some test cases and see what happens. What if I said suppose I'm expecting my amount to be 200. One failed. So you see, this thing is actually capable of detecting problems because these asserts are mainly related to the business logic you have written. And that is how you should be. So every time if your code is updated, suppose you have written an unit test and for some reason the business logic is updated, you have to change the test code. And why it is relevant, suppose you have written the right business logic. Then after you have left the company, there were test cases and it was passing. Some other developer came in because he is new, that's why he didn't understand the business logic properly and he messed up something. This unit test is actually supposed to detect that. So that is its purpose. Now, one last thing I want to show you. I want to show you how you can use the business-driven, behavior-driven development. So behavior-driven development we saw during my presentation. It can work with this, can be written with this spec flow. So I have the order API feature, and I can write my post-order test case just like this using this language, right? So if you are using this spec flow, it gives you a underlying feature class and also gives you this definition. Suppose, okay, now let's do this. Let's show you. Add, I can. Suppose I want to create test cases for my payment service as well. What do I do? Spec flow, let the file adds. Don't worry about that error. That's the test result thing. Suppose I say payment. Okay. Payment feature, payment API. Create payment Now, this is very simply my post-payment test case, right? So if I'm a project manager or a business analyst or something high level, I'll simply write that and be done with it. I mean, this is the business case. I mean, this is what you use for creating your payment API. And also this is a requirement, right? So I give you the requirement. Now this thing is interesting. If you build it, it actually gives you the features. Then it will also create, I mean, you can create this binding here. It will also give you the binding and you can start developing this thing. Look at my binding for this. It has created multiple methods for me, right? Each method actually maps to that given thing, feature here. Given is this is one method, this is one method, this is one method, this is one method, right? Now take a look at how I have implemented the method. Order API is also an API. It is pretty similar to the payment microservice, except for it is CQRS, but that doesn't matter. Again, I have the test provider in memory server. Then here I post order data to API. I posted order data to API. Then I have a success code. That means the service actually processed the data. I verified the response, and also I check the database. Of course, your test case can be a lot more complex than this, especially if you are creating UI test cases, with whatever test framework you're using, like Selenium or something else. This thing can be very complex. The test cases, especially the UI test cases, are pretty complex. But if you're simply writing test cases for a microservice backend, this should be good enough. But obviously, if you have complex business logics, like maybe a AI implementation or a rule-based AI implementation, then it will be a lot more difficult. So yeah, that's pretty much it. I do not have anything else to show.